Hey everyone, if you're writing C++, you already know it's a super powerful language. But today, we're going to talk about one of its sharpest tools, the algorithm header. Honestly, you can think of it as a secret weapon for writing code that's not just cleaner, but way faster and more reliable. Okay, let's be real for a second. How many times have you been deep in a project and found yourself writing yet another for loop to find something? Or maybe even trying to write a sort function from scratch. We've all been there. It feels like a rite of passage. But you know what? It's also a massive waste of time. So what if I told you that you pretty much never have to do that again? That's right, the C++ standard library, and specifically this algorithm header, gives you this incredible pre-built and super optimized toolkit for exactly these kinds of problems. All right, let's crack open this toolkit and start with the absolute essentials. I'm talking about the tools you're going to find yourself reaching for over and over again, sorting and searching. The two big workhorses here are standard sort and standard find. Now, standard sort does, well, exactly what it sounds like. It'll arrange pretty much any collection of things in order for you. And standard find is your go-to for just locating a specific value inside a bunch of data. Simple, right? But incredibly powerful. And this right here just says it all. Look at the left side. That's the manual way. You're thinking about loops, indices, making sure you don't go out of bounds. It's a whole lot of mental clutter. Now look at the right. One line. With std find, you're not telling the computer how to find the element step by step. You're just declaring what you want. Find this for me. This one little change makes your code so much cleaner and way less likely to have bugs. Okay, so this is where things get really cool. Using standard find is great, but it's a linear search, right? It just checks every single element one by one. But if your collection is already sorted, and that part's super important, you get to unlock a whole new level of speed with tools designed just for that. And this is the magic of binary search. Instead of walking through the whole list, it keeps cutting the search area in half. It's ridiculously fast. The library gives you a few options. STD binary search is a simple yes or no, is the thing I'm looking for in here. But then you have lower bound and upper bound, which are even more useful. They tell you the exact spot an element should go to keep the collection sorted. This is an absolute game changer for managing sorted data. So let's zoom out a bit. We've talked about finding one thing, but what about managing and comparing whole collections of things? Yeah, the library has some seriously sophisticated tools for that too. First up, heaps. Now, I know the word heap can sound kind of scary and academic, but the idea is actually pretty simple. A heap is just a clever way of organizing your data so you can always instantly get the biggest or smallest item. It's basically the engine that makes priority queues work. And the best part is, the algorithm library makes using them an absolute breeze. You don't have to worry about all the complex tree logic under the hood. You just take your regular old vector, call std make heap, and boom, it's a heap. Adding and removing the top element, they're just single function calls. So easy. Okay, next up are set operations. Now, there's one really important rule here. Both of your collections have to be sorted first. If they are, you can do some really powerful stuff. Imagine you have two sorted lists of user IDs. With one call to std set intersection, you can instantly find out which users are in both lists. Or use std set union to get a combined list of all unique users. It turns these complex ideas into a single, easy-to-read line of code. All right, now we get to the really fun stuff. Beyond all the daily workhorse functions, this library has some seriously creative tools that can solve some complex problems in a, well, kind of beautiful way. Let's look at one of my absolute favorites. Have you ever been in a situation where you needed to figure out every single possible arrangement of a group of items? You know, like all the ways you could combine them? This problem is called permutations. And let me tell you, trying to code that from scratch is a real headache. But, you guessed it, there's a tool for that. So, let's take a nice, simple, sorted collection. Just three things, A, B, and C. Now watch this. With just one call to this function, stdnext permutation, bam! It instantly shuffles the elements into the very next possible arrangement, as if you were looking them up in a dictionary. And you can just keep calling it. You can wrap it in a simple loop, and it will just walk you through every single possible combination one by one until it gets back to the start. This is so powerful for solving certain kinds of puzzles or optimization problems. It's amazing. So, as we start to wrap this up, the big takeaway here is really simple, but it's something that can completely change how you write code. It's time to stop reinventing the wheel. And look, this isn't some extra library you have to go find and download. As cpreference.com points out, this stuff is a core part of the C++ language itself. These tools are standard, they are bulletproof, and they are just sitting there, waiting for you to use them. So why bother? Well, first, you're going to develop faster. Second, you'll have fewer bugs, because this code has been tested to death. Third, your code will probably run faster, because these functions are incredibly optimized by people who do this for a living. And finally, your code will just be easier to read. STD sort tells everyone on your team exactly what you're trying to do, no questions asked. And that really brings us to the final thought I want to leave you with. The next time you're coding and your fingers start to type for int I = 0 just to find something in a list, I want you to stop. And I want you to ask yourself this question. What's the first wheel you're going to stop reinventing?